Hello, my name is Daniel, and today we will be going through the AMC 12B from the year 2003, so let's get started. First problem, which of the following is same as this? Okay, so if we see here the signs here, they're just all the same, and if you look at the numbers themselves, the up number is always 2 over 3 of the second number, so the ratio is always 2 to 3, 2 to 3, 2 to 3, up until here also, right? So just obviously this whole thing is just 2 over 3, so the answer is C. Number 2, Al gets the disease algebraitis and must take 1 green pill and 1 pink pill each day for 2 weeks. A green pill costs $1 more than a pink pill, and Al's pills cost a total of $546 for the 2 weeks. How much does 1 green pill cost? Okay, so since he takes the same thing each day for 2 weeks, that means $546. So $546 for 2 weeks, which is 14 days. That means for 1 day, that will be 546 divided by 14, which is $39, right? So this is $39. And he takes 1 green and 1 pink, and 1 green pill costs $1 more than a pink pill. So green equals pink plus 1, right? But then since we are solving for green, and let's put this in terms of P. So pink equals green. Yeah, pink equals green minus 1, right? So 39 equals green plus pink. Green plus pink equals 39. But then since pink equals green minus 1, if we substitute that in there, so green plus green minus 1 equals 39. So 2 green would equal 40. So 1 green would equal $20. So the answer is $20. It's D. Number 3, Rose fills each of the rectangular regions of her rectangular flower bed with a different type of flower. The length and feet of the rectangular regions in her flower bed are shown in the figure. She plants 1 flower per square foot in each region. Asters cost $1 each, begonias $1.50 each, cannas $2 each, dahlias $2.50 each, and eastern lilies $3 each. What is the least possible cost in dollars for her garden? For us to get the least possible cost, then we need to plant the cheapest plant in the plot with the largest area, right? So let's just all solve for the area. This has 21, this has 20, this has 6, this has 15, and since this is 2 and 2, the middle one is just 4, right? Since asters cost the cheapest, then we will put the cheapest in the most land. So that's the most land, so that's asters, so times 1. And then the next cheapest is the next biggest land, so this is times 1.5. And in the same way, we will just do everything. Cannas has 2, so this is times 2. This is the next biggest, so this is times 2.5. And this is the smallest, so that will just get times 3, right? So for everything, if we add them all up, 21 times 1 is 21, and 20 times 1.5 is 10 times 3, so that's 30. 15 times 2, that's also 30, so that's also plus 30. This gives us 3 times 3, so that gives us, that's 3 times 5, so that's 15. And then this is 4 times 3, which is 12, right? And so if we add these all, it becomes 60 plus 21 plus 15 plus 12, which is 40, which is 48. So this whole thing is $108. So the answer is A. Number 4, Mo uses a mower to cut his rectangular 90-foot by 150-foot lawn. The swath he cuts is 28 inches wide, but he overlaps each cut by 4 inches to make sure that no grass is missed. He walks at the rate of 5,000 feet per hour while pushing the mower. Which of the following is closest to the number of hours it will take Mo to mow his lawn? Okay, so since he cuts 28 inches, but he overlaps each cut by 4 inches, right? So this part means that if we don't think about the overlap, right, then we would have non-overlap. This would give, each swath would be 24 inches, right? 24 inches, which is 28 minus 4, right? So 24 inches, which is 2 feet, right? And so he will, so that means 1 cut is equal to 2 feet, right? So the total length that he walks is 150 times 90 divided by 2, which is 6,750 feet, right? So he walks 6,750 feet, and so 6,750 divided by 5,000, right? Because he walks at a rate of 5,000 feet per hour. This equals these two cancel, and that's just 675 times 2 is 1350. Oh, sorry, it's 1350 over 1,000. So this is 1.35 hours. So this is the answer. It's C. Number 5, many TV screens are rectangles that are measured by the length of their diagonals. The ratio of the horizontal length to the height in a standard television screen is 4:3. The horizontal length of a 27-inch television screen is closest in inches to each of the following. Okay, so first we'll draw a 3 to 4 to 5 triangle. This is right angle, and this is 3. This is 4, then this would be 5, right? And so this would be like the size of the television screen. And so we want the horizontal length of a 27-inch TV screen, right? So this much is, so this is 27 inches, and we want the horizontal length, so we want that length. So this is how much, right? So if we say this is x, right, then x would equal 27 times 4 over 5, right? Times 4 over 5. This will equal 21.6, which is closest to 21.5. So 21.5 is the answer. It's D. Number 6, the second and fourth terms of a geometric sequence are 2 and 6. Which of the following is a possible first term? So we have something 2, something 6, and if we say that the first term is a, and the common difference is and the common ratio is r, then we would have ar squared, and ar cubed, right? So from these two, we get that r squared equals 3. So r would equal plus or minus root 3, right? And so since ar equals 2, a would equal 2 over r, and so this would be 2 over plus or minus root 3, right? And which of these the following is a possible first term, so we want a values. And so a can be either plus 2 root 3 over 3 or minus 2 root 3 over 3, right? Okay, so we need to find either this value or this value in the answer choices, and we see this value, which is B. It's B. Number 7, penniless Pete's piggy bank has no pennies in it. Okay, so he's really penniless, but it has 100 coins, all nickels, dimes, and quarters, whose total value is $8.35. It does not necessarily contain coins of all three types. Where's the difference between the largest and smallest number of dimes that could be in the bank? So he has some number of nickels, dimes, and quarters, right? But then nickels are 5 cents, dimes are 10 cents, quarters are 25 cents, and they all sum to $8.35, so which is 835 cents. And so we can divide all this by 5. And so that will give us values of this would be 1, 2, 5, and the total is 835 divided by 5, which is 167, right? So the total is 167 cents. 167. First we have 100 coins, so n plus d plus q equals 100. If this is the number of nickels, this is the number of dimes, and this is the number of quarters, right? And then for the total amount, we have 1n plus 2d plus 5q. This is equal to 167, right? 167. And if we subtract these two, then that will get us d plus 4q. d plus 4q equals 67. And we want the largest and smallest number of dimes. So if d is the maximum, that will be when q is equal to 0, so d is equal to 67. And the minimum, that will be when q is the biggest it can be, so q would be equal to 16, and so then d would be 3, right? So this is the maximum, this is the minimum, so the difference between that is 64. So 64 is the answer. It's D. Number 8, the club of x denote the sum of the digits of the positive integer x. For example, club of 8 is equal to 8, and club of 123 is 1 plus 2 plus 3 equals 6. For how many two-digit values of x is club of x equals 3? Okay, so since the club of x equals 3, and this is the sum of the digits, right? Then club of x, this can be 3 or 12, right? Because it has to be two-digit numbers, so x cannot be it can't be over 99, right? So if club of x equals 3, so if it's 3, then x can be 30 or 12 or 21, right? But if club is 12, that means the sum of the digits is 12, so it's all the way from 39, 48, 57, and then 66, all the way to 75, 84, and 93, right? And so this is it. So we have 3 values here, and we have 3, 4, 5, 6, 7, 8, 9, 7 values here. That added up is 10 values, so the answer is 10. It's E. Number 9, let f be a linear function for which f6 minus f2 equals 12. What is f12 minus f2? Okay, so since it's a linear function and it's giving us so the difference of the y values equals 12. So 6 minus 2 under f6 minus f2. This equals 12 over 4, which is 3. But then we see that this is the slope, right? It's the slope, right? And then we want f12 minus f2, but then the slope, which is 3, equals f12 is equal to f12 minus f2 over 12 minus 2, right? And 12 minus 2, this is equal to 10. So if this 10 moves here, then 10 times 3 equals f12 minus f2. So 30 equals f12 minus f2. So that's what we want, right? So the answer is 30. It's D. Number 10. Several figures can be made by attaching two equilateral triangles to the regular pentagon ABCDE in 2 of the 5 positions shown. How many non-congruent figures can be constructed in this way? So we basically have to decide the distance, so the gap between these 2 equilateral triangles, right? So the gaps can be 0 apart, or 1 apart, or 2 apart, or 3 apart, right? And 4 apart is not possible because there's a total of 5, right? And so if it's 0 apart, then it's this and this together, right? So that will be 0 apart, but that will be the same thing as being 3 apart, right? So this and this is the same thing. And for 1 apart, we would have like this thing, and we would have 1 apart, so to make it this thing, right? So that is 1 apart. But then if you see here, that's also 2 apart, right? So this is the same thing. So we have 1, 2 congruent figures, so we have 2. The answer is B. Number 11. Cassandra sets her watch to the correct time at noon. Actual time of 1 p.m. She notices that her watch reads 12:57 and 36 seconds. Assuming that her watch loses time at a constant rate, what will be the actual time when her watch first reads 10 p.m.? The actual time should be 1 p.m., but it was 12:57 and 36 seconds, right? So we can say that the real time was when 1 hour passed, right? And this is equal to 3,600 seconds, right? But then the watch time, this was 57 minutes and 36 seconds passed, right? And so this means it lost 2 minutes and 2 minutes 24 seconds, which is 120 plus 24, which is 144 seconds, right? And so this means that the watch lost, every 3,600 seconds it lost 144 seconds, right? And so if we divide everything by 144, then it means that every 25 seconds it lost 1 second, right? The watch time of 24 seconds, watch time of 24 seconds increase equals real time 25 seconds increase. 25 seconds increase, right? And so real time should be, that means to get real time, this would equal watch time multiplied by 25 over 24, right? And since at 10 p.m. this is the watch time, so watch time is 10 hours, so watch time 10 hours. This 10 hours, which is 10 hours, which this is 600 minutes, right? So what we have to do is multiply 25 over 24. So 600 times 25 over 24. This is equal to adding 25 minutes to 1 hour to the 10 hours, right? So this is 10 hours 25 minutes. So it's 10:25 p.m. The answer is C. Number 12. What is the largest integer that is a divisor of n plus 1, n plus 3, n plus 5, n plus 7, n plus 9 for all positive even integers n? So since n is positive even integers, that means these are consecutive odd numbers, right? So those are five consecutive odd integers, and so this means that in here there must be at least one multiple of 3, and also at least one multiple of 5, right? There are no more numbers that we are sure that is a divisor of everything. So the largest divisor, this is 3 times 5, which is 15. So it's 15, it's D. Number 13, an ice cream cone consists of a sphere of vanilla ice cream and a right circular cone that has the same diameter as the sphere. If the ice cream melts, it will exactly fill the cone. Assume that the melted ice cream occupies 75% of the volume of the frozen ice cream. What is the ratio of the cone's height to its radius? Okay, so if we bring out the diagram of the ice cream cone right here, so this would be the sphere of vanilla ice cream, and this right here, that would be the cone, right? And they have the same diameter. That means they also have the same radius, right? So let's say that this is the radius of the cone as well as the sphere, and let's say this is the height of the cone, right? So height would be h. And so since the melted ice cream occupies 75% of the volume of the frozen ice cream, that means, so first let's look at the cone. Sorry, let's look at the sphere. This would be 4 over 3 pi r cubed, right? And so 75% of this equals 4 over 3 pi r cubed times 3 over 4, and so these cancel, so it's just pi r cubed, right? So this is equal to pi r cubed. This is equal to the volume of the cone, so the cone's volume is, this is 1 over 3 times h times pi r squared, right? Because this is the base and this is the height, and this is because it's a cone. So, and this is equal to pi r cubed. And so if these cancel, then we are left with 1 over 3 height equals r. So height equals 3r. So what is the ratio of the cone's height to its radius? That is 3 to 1. It's B. Number 14, in rectangle ABCD, AB equals 5 and BC equals 3. Points F and G are on CD so that DF is 1 and GC is 2. Lines AF and BG intersect at E. Find the area of triangle AEB. Okay, so we want to find this area, right? Find the area of this one. First of all, we can see that FG, this has length of 2, right? This has length 2. So this has length 2, right? And then the next thing that we see is that this triangle is similar to this triangle that we're trying to get, right? And so if we draw a line from E to E perpendicular to AB, right? So if we draw a line from here, perpendicular like that, right? So like that. Then let's say that this length is A, right? And this length will be 3, right? Let's do that in black. So this length would be 3, right? And so since they are similar, right, that means the ratio of this to this is equal to the ratio of this to this, right? And so this to this ratio, that is A to 2, so A over 2 is equal to this over this ratio, so that is just A plus 3 over 5, right? So if we cross multiply, we get 5A equals 2A plus 6, so 3A equals 6, A equals 2, right? Find the area of AEB. So AEB, this is equal to 1/2 times AB, which is 5, times E and times the height, right? Which is A plus 3, which is 5. So this is 25 over 2. So this is 25 over 2, and it's D. Number 15, a regular octagon ABCDEFGH has an area of 1 square unit. What is the area of the rectangle ABEF? Okay, so first of all, let's draw some lines like this. Since this is a regular octagon, that means this length equals this length. So if we set this much as if we set this much as A, right? If that's A, then this would be root 2a, right? So that means AB, this would also be root 2a, right? So what we can do is get the separate areas of this middle square, and then get the areas of these triangles, of these 4 separate triangles, and then finally get the area of these rectangles, right? And then just add them all up, right? So the middle square, that's just root 2a times root 2a, so that's 2a squared, and then for the 4 triangles, that will just be 4 times, and then that will be 1/2 a squared, because this this much is a, and this much is a. So that's just a, so 1/2 times a squared. And then lastly, we have plus 4 of these. So that's 4 times, and then this is root 2a times a. So this is all going to be equal to 2a squared plus 2a squared plus 4 root 2a squared, which is a squared times 4 plus 4 root 2. But then it said that the area is 1 square unit. So this gives us that this is equal to 1. So a squared equals 1 over 4 plus 4 root 2, right? And we want the area of the rectangle ABEF. So ABEF is this one, right? So I'll just say, yeah, that's this one. And so that would be root 2a times this much BE. That will be equal to a plus root 2a. So 2a plus root 2a. This is a squared times 2 root 2 plus 2. So that's 2 root 2. 2 root 2 plus 2. And so since a squared is 1 over 4 plus 4 root 2, this is 2 root 2 plus 2 over 4 root 2 plus 4, which is 1 over 2. So this is the answer. It's D. Number 16, 3 semicircles of radius 1 are constructed on diameter AB of a semicircle of radius 2. The centers of the small semicircles divide AB into 4 line segments of equal length as shown. What is the area of the shaded region that lies within the large semicircle but outside the smaller semicircles? Okay, so for this we're just gonna need to draw some lines, and they will just be connecting these, and we will also be bisecting these ones also. So like that, a straight line, and same thing for here. Let's divide that into 60 and 60 degrees. Right. Okay, so now to get to this shaded area, we will need the area of this whole semicircle. From that, we will have to subtract 5 of these kind of like what do you call it, fan-shaped things, right? And then we also have to subtract this much, 2 of these triangles, right? And so first of all, the red part, this would be half of 2 squared pi, right? Because 2 is the radius, so this is equal to 2 pi. For the 5 fans, this would be 5 times this, each central angle is 1 over 6, so that's 60 degrees. So it's 1 over 6 times the whole circle, 1 over 6 times the whole circle, 1 squared pi. This is equal to 5 over 6 pi, right? And then this last one, this is equal to 2 times root 3 over 4 times 1 squared, right? So this is, because this is the area of the triangle and there are 2 of them. So this is equal to root 3 over 2. And so what we have to do is this plus this minus this. And so if we do that, we get 2 pi minus 5 over 6 pi minus root 3 over 2, which is 7 over 6 pi minus root 3 over 2. So this is the answer. It's E. Number 17, so if log xy cubed equals 1 and log x squared y equals 1, what is log xy? So let's say that log x, this is equal to a, and log y, this is equal to b, right? Then log xy cubed, that would be a plus 3b, and this would be equal to 1. And for this one, it will be 2a plus b equals 1. Right, and so from here we can say that b equals 1 minus 2a, and if we substitute that into there, then we will get a plus 3 times 1 minus 2a is equal to 1. So a minus 5, so a minus 6a, which is negative 5a. This plus 2, so this plus 2 equals 1. So sorry, equals 0. So that means 5a equals 2. 5a equals 2. So a equals 2 over 5, right? And since a equals 2 over 5 and b equals 1 minus 2a, b equals 1 over 5, right? And we want log xy, which is just log x plus log y. So this is equal to a plus b. So we have wanted a plus b. A plus b equals this plus this, which is 3 over 5. So this is our answer. It's D. Number 18, let x and y be positive integers such that this is satisfied, and the minimum possible value of x has a prime factorization of a c, b, d. right? So it's a to the cth power and b to the dth power. What is a plus b plus c plus d, right? So first of all, since we want the minimum possible value of x, then we can see that a and b, these are the bases. They all have to be 7 and 11 because these have 7 and 11 in them, right? So first of all, a and b equals 7 and 11. Right, and so if we put ACBD into x, so if we plug that in, that will be 7 times c, so that will be 7 times 7 to the cth power times 11 to the dth power. This all to the 5th power, this is equal to 11y 13th power, right? So this means 7 to the 5c plus 1, 5c plus 1 power, 5c plus 1 times times 11 and 5d, and then this comes over, so 11 to the 5d minus 1 power. This is equal to what? It's the 13th power, right? And so from this we want the minimum. We want the minimum value of c and d, that 5 plus c, so 5c plus 1 equals a multiple of 13, equals multiple of 13, and 5d minus 1. 5d minus 1 is also a multiple of 13, right? Do that. We have c equals 5 and d equals 8, right? So we have c equals 5, d equals 8, and a and b equals 7 and 11. So for a plus b plus c plus d, we can have 7 plus 11 plus 5 plus 8. This equals 31. So 31 is the answer. It's B. Number 19, let S be the set of permutations of the sequence 1, 2, 3, 4, 5, for which the first term is not 1. A permutation is chosen randomly from S. The probability that the second term is 2 and lowest terms is A over B. What is A plus B? Okay, so since this is a permutation, right? That means we only consider the first two digits. So, and this is because on the last 3 digits possibilities, they are all equal, right? So we don't need to care about the later 3, and so we just need the first 2, right? And so the probability that the second is 2, so the possibilities that the second is 2, then this we have first can be 3 and second 2, or first 4 and second 2, or first 5 and second 2. So right, so this we have 3. And for the total possibilities, this is going to be 4 times 4, which is 16. And so this 4 is because the first one cannot be 1, and then this 4 is because the second one cannot be the first number, right? And so that's just 16. So our total is 3 over 16, so 3 over 16, and so A plus B is 3 plus 16, which is 19, so the answer is 19, which is E. Number 20, part of the graph of fx equals this is shown. What is B? Okay, so since this has 0, 2, right, that means D equals 2, so D equals 2. And we have 1, 0 and negative 1, 0, so if we plug that in, A plus B plus C plus 2 equals 0. This is from 1. And negative A plus B minus C plus 2 equals 0. That's from minus 1, right? And so if we add these together, we get 2B plus 4 equals 0. So B equals negative 2. So it's negative 2, it's B. Number 21, an object moves 8 centimeters in a straight line from A to B, turns out at an angle alpha measured in radians and chosen at random from the interval 0, pi, and moves 5 centimeters in a straight line into C. What is the probability that AC is less than 7? Right, so if we pull out a diagram of this, then this would be the triangle, and so we would be moving from A to B, so this direction, and then we would turn at an angle alpha, so this would be the angle alpha, and C would be over here, right? So AB, this would be 8, and BC, this would be 5, right? AC has to be less than 7, right? So what we need to do is we find the probability where AC is actually 7, and then we find the alpha value of that, and then we find the probability that the alpha value is actually less than that value, right? So to do that, we have to first make a straight line from C, so that would be a right angle. So let's say that this part is x, this length is x, and so this will be 8 minus x, right? And this part they both have in common, right? So using Pythagoras for this one and this one, both of them, then we would get that we will get 5 squared minus x squared, that's for this squared, equals 7 squared minus 8 minus x squared, minus 8 minus x squared, right? So we get 25 minus x squared equals 49 minus x squared minus 16x plus 64, and so x squared cancels, so 25 equals 49 plus 16x minus 64, and so 16x equals 64 plus 25 minus 49, and so this equals 40. X equals 40 over 16, which equals 5 over 2. So x equals 5 over 2, and so let's say that this is equal to 5 over 2. Then what would the alpha value be, right? And since this is a right angle and the length ratio is 2 to 1, right? Because BC is 5 and this is 5 root 2. No, sorry, that's 5 over 2. That means this is going to be 60 degrees, but then alpha is in radians, so this means alpha is 60 degrees, which is pi over 3, right? And so the value of alpha can be from 0 to pi, but then it's pi over 3. So we want the probability that AC is less than 7, therefore alpha has to be less than pi over 3. So alpha is less than pi over 3, and so this is pi over 3 over the total, which is pi. So this is equal to 1 over 3. So the probability is 1 over 3. The answer is D. Number 22, let ABCD be a rhombus with AC equals 16 and BD equals 30. Let N be a point on AB, and let P and Q be the feet of the perpendiculars from N to AC and BD respectively. Which of the following is closest to the minimum possible value of PQ? Okay, so first of all, what we need to see is that, let's say that this point is O, right? Then first of all, what we need to see is that the length PQ, this is always going to be equal to the length of ON, right? So always PQ equals ON, always. And why? This is because they are both the diagonals of a parallelogram, right? And so they will also, so PQ and ON, they will always be equal. And so since we want the minimum possible value of PQ, this is equal to the minimum possible value of ON. To get the minimum value of ON, what we have to do is we have to draw a line from O, draw a line that goes right perpendicular to that, right? So this would be N. For ON to be a minimum, that means AOB, this angle, must also be a right angle, right? And so AOB should be a right angle, and this should be a perpendicular line, right? Okay, so now we can use these things. AC is 16 and BD is 30. Since AC is 16, so this is 16, so half of that, this much, that's 8, right? So this is 8, and BD is 30, so this is 30, so that means this is half of it, so that's 15. So this is 15, right? So AB, this is by the Pythagorean triple, we have 8, 15, therefore we will have 17. That's the Pythagorean triple. So AB equals 17, this much is 17, right? And now since we know OA, OB, and AB values, we can use the property that the area times 2 equals OA times OB, which is also AB times ON, right? So these two values multiplied equals these two values multiplied. So if we do that, then we get ON times AB equals OA times OB, right? So ON equals OA times OB over AB. So this is equal to OA is 8, OB is 15, and AB, this is 17, right? So 8 times 15 over 17, this is 120 over 17, which is 7.06 something, which is basically 7, right? So it's closest to 7, so the answer is C. Number 23, the number of x-intercepts on the graph of y equals sine 1 over x in the interval, this one, is closest to, since this is the interval of x, right? That means x is between 1 over 10,000 and 1 over 1,000, right? But then we have sine 1 over x, so if we make this 1 over x, then this means 1 over x is greater than 1,000 and less than 10,000, right? So since this value is the value inside the sine, right? And since the sine of x always has roots at pi n, where n is an integer, right? Since this doesn't have any restrictions pertaining to x, that just means that sine x with its roots of this, that will just be the same when it's sine of 1 over x, and so it will have roots pi n, and that means that the number of roots, this is going to be equal to number of n's when pi n is between this value, right? So when pi n is between 1000 and 10,000, right? So here n will be greater than 1000 over pi and less than 10,000 over pi, right? So the number of n's is equal to 10,000 minus 1000 over pi, which is 9,000 over pi. So it's 9,000 over pi, which is similar to 2,900. So this is the answer, 2,900. So it's A. Number 24, positive integers a, b, and c are chosen so that a is less than b is less than c, and the system of equations this and these, they have exactly one solution. What is the minimum value of c? Okay, so first of all, we know this line, but we don't know this line, so we would have to graph this line to easily see where it could have exactly one solution, right? And so since these are absolute values, then we would do well to separate the ranges, right? So since this is the order, we can have when x is less than a, and when x is between a and b, and when x is between b and c, and when x is larger than c, right? So first of all, when x is greater than a, then we can know the slope, right? And if x is less than a, these three are all going to be negative, so they're all negative, so slope is minus 3. Slope is going to be negative 3, and if it's between this value, if x is between a and b, this is positive, but these two are negative, so this is plus minus minus, which makes the slope negative 1, right? And if x is between b and c, then these two are positive, but then this is negative, so that gives us the slope of positive 1. And if x is greater than c, then that means this is all positive, so the slope will just be 3. Slope will be 3, right? Positive 3, right? And so if we draw a diagram of that, that will look like something like this, right? If you see before a, so if x is less than a, the slope is negative 3, and if a is between a and b, the slope is negative 1. If x is between b and c, the slope is positive 1, and if x is greater than c, then the slope is positive 3, right? And so this would be what it looks like. And then now we can just have 2x plus y equals 2003, and this is equal to y equals minus 2x plus 2003. And so if we graph that, that will look something like this, right? But then since it has to have exactly one solution, then the only way to get that is it intersects the second equation, this one, at exactly this point, right? So that's the only way that these two things, they can have one solution, right? So this is y equals negative 2x plus 2003, and this point, this would be the only solution. So the solution is only when x equals a, right? And since this is possible, right? So that would give us the y value of a. So this will be equal to a comma, and then if x is a, this is going to be OA, and this is going to be negative, so it's going to be b minus a, and this is also going to be negative, so that's going to be c minus a. So if these are added together, then that will be so that will be b plus c minus 2a. So it's a comma b plus c minus 2a. This can be substituted into this, right? So if we put this as x and this as y, then we can say that 2 times a plus b plus c minus 2a, this is equal to 2003, right? So that will give us these two will cancel. So b plus c is equal to 2003. And since we want the minimum value of c, then the minimum c, this is equal to 1002, because b must be less than c, so c must be greater than b. And so if b plus c equals 2003, the minimum of c is 1002 when b equals 1001, right? So the minimum is 1002. So the answer is C. Last problem, number 25. 3 points are chosen randomly and independently on a circle. What is the probability that all 3 pairwise distances between the points are less than the radius of the circle? Okay, so let's bring out a circle, this one here. And now we need to put on 3 points, right? So we have the first point. This is going to not matter where we put it. So this is gonna not matter, right? So let's just say that we put it over here, and then let's say we need this, yes, and then we have the second point, right? Second point, this will be within 120 degrees of the center, right? So if we see that the center is here, then the point is going to be between this point and this point, where this and this, yeah, where this much, this length, this angle is 120 degrees, right? And so that and so this is because the distance are, right? The reason for this is because since the distance between points is maximum of radius. Maximum would be the radius, right? So radius, so that means one radius. So one radius away is the maximum point. So that means one radius is exactly 60 degrees on each side of first point, right? That is why if we do here, this is 60 and this is 60 degrees, and so that's why we have 1/3 of the whole length, right? So this is 1/3 of the whole circumference. So that's probability is 1/3. And for the third point, we have a minimum and a maximum, right? Because the minimum, that would be when the second point is like on here or on here, right? So if that happens, then the distances have to be less than the radius of the circle. So the last point would have to be within here somewhere, right? So that would be 1/6 of the whole thing, right? So minimum is within 60 degrees of the center, so that's 1/6. Maximum, that would be when the second point is just equal to the first point, right? So that would be same thing as the second point, so that would just be also within 120 degrees of center, so that would also be 1/3, right? And so this is when point two is on is in the max distance, and the maximum, this is when point 2 equals point 1, right? And so for this one, we have a range of different values, with 1/6 being the max, with 1/6 being the minimum, and 1/3 being the maximum, right? And so this for this, we need to have a average probability, which is going to equal 1/4, right? It's just not matter, so that's a probability of 1. So now if we multiply 1/3 and 1/4 together, that will give us our answer. So 1 times 1/3 times 1/4, this is 1/12, right? So 1/12 is our final answer. It's D. So that was it for the AMC 12B from the year 2003, and thank you for watching.